to finish it today. So what is friction? Friction is basically an force which opposes relative motion between bodies. Friction is a force which opposes relative motion between bodies. Force which oppose relative motion. So the force which opposes relative motion is known as frictional force. There are a few examples of frictional force, or few examples that can convince you that some friction is always there in between the bodies. Like if this is car, this car is moving with a velocity of 100 km per hour. This is moving on a straight road with a velocity of 100 km per hour. The engine of the car is on. At some point of time, I just switch the engine off. I'm not applying any opposing force. So ideally, this car should continue to move with 100 km per hour even after I switch off the engine. Because to move a body with a constant velocity, you don't need force. You need force either to increase velocity or to decrease velocity. So ideally, what should happen that off the engine, then car should continue to move with the same velocity. Its velocity should not change. But in reality, what happens? As soon as I switch the engine off, the car will stop after covering certain distance. It will comes to rest. The initial velocity of the car is it's 100 kilometer per hour. If it comes to rest, its final velocity becomes zero. So if its velocity is decreasing, that means a force is acting on the car in a direction which is opposite to the motion of the car. So this force which is acting in a direction opposite to the motion of this force will stop the car. And this force, by the way, is known as frictional force. So there is a frictional force between the road and the tire, and that frictional force force the tires to stop, force the car to stop. So friction is simply a force which opposes relative motion. This is one example for the existence of friction. Next, you can divide your friction. This I have already discussed. I'm just repeating it again. We can divide friction into two parts. Your friction could either be internal friction or your friction could be external. Internal friction basically acts in fluid. It acts between the layers of liquid, it acts between the layers of gases. So internal friction, it acts between layers of fluid. It's internal because it's not acting between two different bodies. It's acting between the layers of the same liquid or the layers of the same gas. This is known as viscosity. Usually, the friction which acts between the layers of the liquid or the layers of gases, we don't usually call it friction. We call it viscosity. This is known as viscosity. So I'm not right now discussing viscosity. This we will do in second book. This is in fluid dynamics, your ninth or maybe 10th chapter. Right now we are interested in external friction. This external friction acts between two different surfaces. The example that I gave here, the friction between the road and the tires of the car. This friction acting between the road and the tires of the car is basically an external friction. It acts between two solid surfaces in contact. Now, this external friction can be further divided into two parts. The external friction can be further of two types. One is rolling friction. Rolling friction is basically the friction which is acting between the tires of the car and the road. So the friction acting between the tires and the road is rolling friction. Then another friction after rolling friction, another type of friction is known as sliding friction. This is sliding friction. Okay, can you guess out of rolling and sliding friction, which one is less, which one is smaller? Rolling or sliding?
Rolling
Rolling
is
friction is
smaller.
less.
Yeah.
Yes, rolling friction is smaller. Rolling is very, very less as compared to sliding friction. That's why the wheel of the car or the wheel of the vehicles are in circular shape so that they can roll. Rolling is very, very less than sliding. In fact, if you compare rolling and sliding, you can simply neglect your rolling friction as compared to sliding friction. Now, this sliding friction, we can divide this sliding friction further into three parts. Your sliding friction could be static. Your sliding friction could be limiting. Your sliding friction could be kinetic. So these are three types of sliding friction. It could be either static, it could be limiting, or it could be kinetic friction. So these are the various types of frictions. So we will, in this chapter, we will concentrate on sliding friction only. We will do rolling friction, just one or two statements about rolling friction. But in detail, we will be doing these three types of friction. Now let's see what is static, limiting, and kinetic friction. Static, limiting, and kinetic friction. So let's first see what is static friction. Basically, static friction is the friction which is acting on the body when the body is at rest. So until the body remains at rest, the friction acting on the body is static. Limiting is a type of static friction. Limiting is basically maximum value of static friction is limiting. So starting and limiting both acts when the body is at rest. But when the body starts moving, then the friction which is acting on the body is known as kinetic friction. Now let's see these types of frictions in detail. Let's start with static friction. Let's start with static friction. So it's a surface, it's a rough surface. Over this rough surface, I place the block. I applied a force of 1 Newton over the block. F1 equal to 1 Newton. But the block does not move. If this block does not move, that means this floor is exerting a frictional force of 1 Newton over the block. If block doesn't move on applying a force of 1 Newton, that only means that net force on the block is zero. The net force on the block is zero. That means in the direction opposite to the applied force, you're getting a force which is frictional force of same 1 Newton. Next, I increase the applied force F1 equal to 2 Newton. The block doesn't move. Fatma, can you guess the value of frictional force now? Since the block does not move, so the friction now should be good. 2 Newton so that it can balance the applied force. If I increase the value of the applied force, this is F2, F3 equal to 3 Newton. And I'm saying that body still doesn't move. That means the frictional force acting on the body, F3 is 3 Newton. So this friction which acts on the body until the body remains at rest with respect to the surface is known as static friction. This is static friction. And as you can see, the static friction is not constant, it's self adjusting. When your applied force was 1 Newton, your static friction is 1 Newton. When your applied force becomes 2 Newton, it becomes 2 Newton. When your applied force becomes 3 Newton, it becomes 3 Newton. Oh, Sani, tell me one thing. If I decrease the value of external force to 1 Newton, then what will happen with friction? It will remain 3 Newton or it will also decrease?
It will also decrease.
It will also decrease. If you decrease the value of applied force, then your friction will also decrease. So in that sense, we call that static friction is self-adjusting. For static friction, first thing is it acts when body is at rest with respect to surface. Body doesn't move with respect to surface. In that case, the friction which is acting over the body is static friction. And there's one more important thing about static friction. It is self-adjusting. It is self-adjusting. It changes with the applied force. It changes with applied force. So after static friction, the next thing is limiting friction. See, there is a maximum value of friction that surface can offer. Who is applying friction? The surface is applying friction over the block. There is one maximum value, that the maximum value of friction which this rough surface can apply over the block. And that maximum value of friction is known as limiting friction. So limiting friction, it is the maximum value of static friction. The maximum value of static friction is limiting friction. It usually acts when body is just at the verge of motion. Verge of motion means body is just about to start. If in the same example I keep on increasing the force, like say I applied 4 Newton and the body doesn't move, that means friction is 4 Newton. But see, this 4 Newton is the maximum value of force that I can apply until the body moves. Means if I increase the value of force just a little bit, like I increase the value of force up to 4.001 Newton, the body starts moving. So that means the maximum friction that this surface can offer is 4 Newton. Because if I increase force from applied force from 4 Newton, then this body starts moving. So the maximum friction that this surface can offer is known as limiting friction. In this particular example, its value is 4 Newton. So up to limiting friction, body does not move. But once your applied force exceeds the force of limiting friction, then body starts moving. So that's why I'm writing is at the verge of motion, just about to move. But the actual motion have not started yet. So that was about limiting friction. Now, if I apply force which is greater than force of limiting friction, say for a surface, the surface can exert a maximum limiting friction, maximum friction of let's say 5 Newton. If I apply a force which is greater than 5 Newton, then this body will start moving. And once body starts moving, then another type of friction acts on the body, which we call kinetic friction. kinetic friction. So it acts when body is actually moving over the surface. Is actually moving over the surface. So if the body is actually moving over the surface, then the friction is kinetic friction. So if I apply a force which is greater than 4 Newton, means if I apply a force which is greater than force of limiting friction, then body starts moving. Now, can you guess if body keep on moving, then can you just compare the limiting friction, kinetic friction? Kinetic friction should be equal to limiting friction. It could be greater than limiting friction, or it should be less than limiting friction. What do you think? Kinetic friction?
It should be less than limiting friction.
Everyone agree with Noor that it's less than limiting friction? Everyone agree with Noor that kinetic friction should be less than limiting friction?
Sir, can you repeat the question again?
Yes. This limit, if I compare limiting friction and kinetic friction, then kinetic friction is less than limiting friction. Kinetic friction could be equal to limiting friction, or kinetic friction should be greater than limiting friction. Just compare kinetic and limiting friction. Okay, let's understand this concept through an example. Let's assume it's a rough surface, and over the rough surface, I applied a block. This block is at rest. To move this block, and applying some force F. Now, this you have to imagine a few things. Say, consider a very heavy block placed on the floor. You are pushing that box. Just to move that box from rest to the motion position, you are applying some force. You're continuously applying force over the box. But just to bring this box from rest to motion, you're applying some force. Now this box starts moving. Do you need the same force to keep this box moving? Equal to the force that we require to move this box from the rest. Now I'm applying some force to bring this box from rest to motion. Then applying force to keep this box in motion. Like say I apply force F1 to bring this box from rest to motion. Then I'm applying some force F2 to keep this box in motion. Can you compare F1 and F2? Which one is less?
F2 is less than F1.
F2 is less than F, because once this box starts moving, you need a comparative lesser force to push it. But to start this box from rest to motion, you need a comparative higher force. So in this way, you can compare that kinetic friction is actually less than limiting friction. Once the body starts moving, you need comparative less force to keep it moving. But at the first place, to make this body come at motion from rest, you need a comparative higher force. So kinetic friction is always less limiting friction. Just a second. So there's one question. You can ask you to plot frictional force versus applied force graph. So to draw this graph, I don't have any equation here to draw this graph. This graph will be qualitative. So just imagine a very heavy box placed on the floor. You are pushing that box, and the force with which you are pushing the box, you will keep on increasing the magnitude of that force. Now you have to visualize what will happen with the frictional force. If my applied force is zero, how much is friction? I'm not applying it.
0.
Friction is zero. If I keep on increasing the applied force, the friction keep on increasing until the box is at rest. Padma, which friction keeps on increasing until the box is at rest? Is it kinetic, limiting, or static? Fatma, the box is at rest. Listen, question. The box is at rest. I'm applying the applied force. Box have not yet moved. Box is at rest. Which force of friction will increase?
Kinetic
Kinetic will act only if your body comes in motion. And
or
your box,
limiting?
your box is at rest. If your box is at rest, then the friction acting over the box is static or kinetic. Limiting
Correct.
maximum value of static friction, the static friction keeps on increasing. I'm saying that box is not moving, means if this is your box, the same example that I have given in the last slide, this is box of mass m. I applied a force of 1 Newton. I'm pulling this with a force of 1 Newton. It doesn't move. That means friction is 1 Newton. Which friction? Static friction. I applied a force of 2 Newton. The box does not move. That means the friction acting over the box is 2 Newton. When box doesn't move, that means the friction is static. So if I keep on increasing the applied force, so the movement up to which your box remains at rest, the friction is yours limiting friction. Sorry, it's static friction which keeps on increasing. But once your box starts moving, then Fatima kinetic friction will act. And that kinetic friction, what do you think, would be greater than limiting friction? Or it would be less than limiting friction.
Less than.
Yeah, then that kinetic friction would be less than limiting friction. So to plot graph, this thing should be very clear that if you keep on increasing the force, then first static friction will increase. Then it will reach a maximum value, which we call limiting friction. If I increase the force further, then that limiting friction will decrease, and then your friction will be kinetic friction. Okay, just by looking at the graph, you have to identify up to which region the friction is static, which is the case of limiting friction, and which one is kinetic. This is your applied force. This is your friction. This is your frictional force. And this is the graph. This is the graph. This is O. I call this as A. I call this as B, and this is C. Fatma, can you identify which region is the of static friction? OA, AB, or BC? Which region is of static friction? No. Fatma, see, static friction increase with the applied force. When your applied force is zero, yes, your static friction was zero. As you keep on increasing your applied force, your static friction keep on increasing. So this O to A is your static friction. This hole is your static friction. This is your static friction. This hole is your static friction. Then, corresponding to this point A, your static friction is maximum. So
Limiting.
point A, yes, it corresponds to limiting friction. It corresponds to limiting friction. And then once the body starts moving, then
Kinetic.
it decreases. If it decreases, then this is basically your kinetic friction. So if you keep on increasing the applied force, first your static friction increase, it reaches to a maximum value. That maximum value is limiting friction. If you increase your applied force further, then your friction decreases, and that is your kinetic friction. The next is the cause of friction. The next is the cause of friction. The cause of friction, basically there are two views, one old view and then modern view. I'm not discussing the old view, that was incorrect. So the modern or the correct view is the friction between two surfaces arise due to intermolecular forces between them. The cause of friction is basically intermolecular forces. So between two surfaces, friction arise due to intermolecular forces. So the cause of friction is its intermolecular force between surfaces is responsible for friction. So the cause of friction is the intermolecular force between surfaces is responsible for friction. If I take two surfaces, let's say I take my hand and this pen, then this pen will have molecules. This hand too have molecules. So this molecules of pen and molecules of hand, if I put them in contact, then they will attract each other. So then they will attract each other. If I want to move this pen, see these molecule of pen and molecule of hand will attract each other. If they attract each other, they will make sort of welding, a sort of cold welding. It seems like they have stick to each other. If you want to move this pen over the surface, then you're applying force against that cold welding or against that sticky force between these two things. So the cause of friction is the intermolecular force between the surfaces. The intermolecular force between this pen and my hand is responsible for the friction acting between my hand and pen. It's responsible for friction. So if I take this surface and I place a block over the surface, and I place a block over the surface. Now the intermolecular force which is acting between the box and the surface is basically friction. Intermolecular force acting between the box and the surface is friction. The molecules of surface will attract the molecules of this box. So if you want to move this force, then that attractive force will oppose the motion. And that is what you call your friction force, responsible for friction. This is sometimes known as cold welding. This is sometimes known as cold welding. This is also known as cold welding. Okay, so that's the cause of friction. Is it clear, the cause of friction?
Yes, sir.
Yes, sir.
Okay. After the cause of friction, then there is laws of limiting friction. These laws of limiting friction simply says the first thing, that friction between two surfaces depends on normal reaction. We have already done normal reaction in laws of motion. So friction between two surfaces depends on normal reaction. So friction depends on normal reaction. Second, frictional force between two surfaces is absolutely independent of area of contact. Friction is independent of area of contact. That means if normal reaction is same, like I take the surface, put a box of mass m in this way. I take the same surface, take the same box, but instead of in this way, I place that box along its length. The mass is same. If mass is same, normal reaction is same, then the same frictional force will act on the box. It's absolutely independent of area of contact. Now the second law of friction. The third law says friction depends on nature of surface. Depends on basically roughness of the surface. Roughness is basically nature of surface. So these are three laws. Basically, the first law we will use for some mathematical calculation. That friction depends on normal reaction. It's absolutely independent of area of contact, and it depends on the roughness. Like if you keep on increasing the roughness of the surface, then friction will increase. This is what happened with the tire on the road. With use, the smoothness of the tire decreases, it becomes rough. When the tire becomes rough, the friction increases. So with time, the friction between the tire and the road keeps on increasing. Sorry, not increasing, keep on decreasing. With time, the tire becomes smooth. So the friction keeps on decreasing. Sorry, it doesn't increase, it decreases actually. It depends upon the roughness. So if the surface becomes smooth, then friction will decrease. Friction increase with roughness. If you keep on increasing the roughness of the surface, then friction will increase. Now let's see how to calculate this limiting friction. See, we cannot calculate static friction because static friction is self-adjusting applied force. What we can calculate is limiting friction. We cannot calculate static friction because static friction is self-adjusting. It changes with the applied force. But what we can easily calculate is limiting friction. The maximum value would remain constant, it's fixed. So limiting friction, to calculate limiting friction, so this is the body. I place this body on the rough surface. The mass of the body is m. So the weight of the body is acting in downwards direction. This is placed on the surface. This surface is exerting some normal reaction in the body. You place this body over the surface is exerting a normal reaction over the body. So the frictional force acting on the body, the limiting friction, is directly proportional to this normal reaction. I'm calculating force of limiting friction. This limiting friction is directly proportional to normal reaction, the normal reaction exerted by the surface on the body. And the direction of friction, okay, that we will discuss later. This is the magnitude. If I remove the sign of proportionality, then I will use a constant, mu L. So it would be mu L into L. This mu L is known as its coefficient of friction, or it's better if I call this as its coefficient of limiting friction. You can even write this thing as this is the maximum value of static friction, which is mu s multiplied by n. This is the maximum value of static friction. That's mu s into n. Here mu s is coefficient of static friction. And remember one thing, coefficient of static friction or coefficient of limiting friction are the same thing. Just the name is different. These are not two different quantities, they're the same quantities. Coefficient of limiting friction and coefficient of static friction, they are same quantities. So that's limiting or static the maximum value. If he asks the question, if you are being asked to calculate the static friction, then remember static friction is less than limiting friction, or should better remember this as static friction is equal to applied force until body moves. Until body is at rest, your static friction will be equal to applied force. And one more thing, if your applied force exceeds this, next is the direction of limiting friction. The direction of limiting friction is always opposite to the tendency of motion. If I'm pulling this body to the right hand side, then the friction will act in the opposite direction. Because if I'm pulling it to the right hand side, that means the tendency of motion of the body is to the right hand side. So the body friction will oppose the tendency of motion, so it will always act in opposite direction. So you can say direction of friction is opposite to the applied force. In few questions, maybe you cannot get applied force. So the direction of friction is opposite to the tendency of motion. See, this is limiting. Body is not moving, but the direction in which body could move, this limiting friction will oppose that direction. Let's say if I take this surface and I say that this body, I take the surface, this body of mass m, and I'm saying that body can move to the left hand side, then friction will definitely act to the right hand side. So that's limiting friction. So to calculate limiting friction, this is coefficient of limiting friction multiplied by n, normally action, where n is normally action. N is normal reaction. And one more thing, this mu L is a unitless quantity. Coefficient of friction doesn't have any unit. It's limitless. And one more thing, this mu L depends on the roughness of the surface. Mu L depends on roughness. It increases with the roughness. A surface having higher value of mu is rougher. Let's take a very small example for use of this formula. Let's see, I take this box. I place this box over the rough surface. Mass of the box is 10 kg. The coefficient of friction between the box and the surface is 0.5. This is coefficient of limiting friction. So calculate first part. Force of limiting friction. So first of all, you have to calculate the normally action. So this is a very simple problem to calculate normally action. This is weight is 10 kg, mass is 10 kg, its weight would be 10 g, and there is one normally action acting in upwards direction. The system is in equilibrium. That means in equilibrium, the normally action will exactly balance the weight. So you can write that your normally action is equal to 10 g. You can write that your normally action is 10 into 10. You can write that your normally action is 100 Newton. This is the normally action of the body. The coefficient of friction is 0.5, limiting friction. You can easily calculate your force of limiting friction. The force of limiting friction is mu L into N. The force of limiting friction comes out to be mu L, which is 0.5, multiplied by normally action, which is 100. The force of limiting friction comes out to be 15. Is it clear? The part 1 of the question.
Yes, sir.
Yes, sir.
Fatma, Rania, these calculations have nothing to do with the topic that you have missed. It's a fresh calculation. This is mu into N.
Yes, sir.
Okay. Now, once you have force of limiting friction, the second part, he asking you to calculate static friction. The applied, so if on this surface, the maximum friction, you can write this as limiting friction, or you can write this as maximum value of static friction, which is 15. The applied force is, here the applied force F is, in the first part is 30 Newton. And force of limiting friction, we know this is 50 Newton. Fatma, Farhana, just decide whether the body will move or not. Yes, body will not move because your applied force is very less than the maximum value of static friction. If your applied force is less than the force of static friction, then obviously your body will not move. Now, if body doesn't move, that means the friction is static in nature. Now, can you guess the value? See, this limiting friction of 50 Newton is not actually acting on the body. This we have calculated the maximum value of friction which surface can offer. If your applied force is 30 Newton, we have seen that the static friction is self-adjusting. If body doesn't move, then static friction always adjusts itself equal to the applied force. So if your applied force is 30 Newton, then force of static friction, which should be equal to applied force, is 30 Newton. I'm repeating it again. By calculating force of limiting friction, it does not mean that actually this much force is acting on the body. This means force of limiting friction means the maximum force which can act on the body is 50 Newton. The maximum force that surface can exert on the body is 50 Newton. But if your applied force is 30 Newton, then surface will not exert 50 Newton. Surface will exert only 30 Newton. If your applied force becomes 40 Newton, then surface will exert 40 Newton. That's static in nature. If your applied force becomes 50 Newton, then your surface will exert force of 50 Newton. Body will remain at rest. Is it clear? This thing? The difference between the static friction and the limiting friction?
Yes, sir. It's clear.
Because sometimes it's very confusing that he asks you to calculate static friction. You calculated, okay, your limiting friction comes out to be 50 Newton. But the answer would be given that static friction is equal to applied force equal to 30 Newton. So for these things, always keep in mind that when we are calculating limiting friction, what we are calculating is the maximum friction that surface can exert. It's the maximum friction that surface can exert. Surface not exerting this friction. The friction that surface will exert will depend upon the applied force. Yes, if your applied force is 50 Newton, then yes, your friction would be 50 Newton. Then your static friction will become equal to limiting friction. If applied force becomes 50, then friction will become 50. Now, part 3 of the question. Fatma Farhana, just try again. Now your applied force is 60 Newton. And the maximum friction that surface can offer is 50 Newton. What do you think? Body will remain at rest or it will move? The surface, the maximum friction that surface can offer is 50. Means maximum opposition that surface can offer is 50. But I'm applying a force which is greater than 50, 60 Newton. Yes, body will move. Your applied force is greater than force maximum friction. So body will move. Okay, now can you guess which friction will act on the body in third case? Will it be static? Will it be limiting? Or it would be kinetic?
Kinetic friction.
Yes, because in third part, body is moving. So kinetic friction will act on the body. Kinetic friction will act. But we don't yet know how to calculate kinetic friction. That we will do in the next section. But the motive of this numerical was just to realize which friction will act. When we calculate limiting friction, we are basically calculating the maximum friction that surface can offer. Actually, what's the value of friction will always depend upon the applied force. So let's erase it and start with kinetic friction. The formula of kinetic friction is almost same as that of limiting friction. The only difference is in the coefficient. The kinetic friction is again equal to mu k into n. But here mu k is coefficient